All right, good evening, everyone, and welcome to the Marshall W. Allworth Planetarium. My name is Jessica. I am the director and will be your tour guide to the night sky tonight. You've also met two of our students who are currently working tonight. We got Brayden, who's in the back right now, and then you also met Rachel at the door. Tonight's show is all about exploring what we can see up in the September sky. So we'll take a look at some constellations, some planets, some deep sky objects, things like that. If you have questions anytime throughout the show, feel free to ask. We, want to be able to answer your questions. And yeah, that's it for now. If you do need to leave anytime during the show, you can exit through the same door you came in. Just be careful because it's dark. Yeah, that's it. I'm gonna head to the back and we'll get started. All right. So we are currently looking at the sky now. We've got the sun setting over in the west, so we're not quite into dark yet. I'm going to fast forward time just slightly so that we can at least get to sunset. And do a little bit of planetarium magic to get rid of these clouds. So currently, over in the west, we have the planet Mars hanging out really low in the west, right at sunset. Mars has been visible in the night sky for months and months now, and it's just starting to get out of view. So you may be able to see it right as the sun sets, but it's going to start slowly getting closer and closer to the sun. So we're not really going to be seeing Mars much for the next few months. And everything else, we're going to have to get a little bit darker. So I am going to fast forward time again until the sun is well below the horizon and we have nice dark skies. There we go. Much better. So for this time of year, we're looking at about 9:25 for good dark skies. Now this is showing skies without light pollution, so this is not what you would see downtown Duluth. But if you're able to get out of the city, this is more of like what you will see. So we'll begin here in the north. Up in the northwest this time of year, we have 7 bright stars, which make up the Big Dipper. Now, the Big Dipper is not a constellation itself. It is actually an asterism. So that means it's a smaller part of a larger constellation. In this case, the Big Dipper is the 7 brightest stars in the Greek constellation of Ursa Major, or the Big Bear. So to see the full bear, we have to add in some other stars. The handle of the Big Dipper is the tail of the bear. The cup of the Big Dipper is the kind of back half of his body. And then we add in some extra stars to get the head and legs of our big bear. And this time of year, the bear is kind of walking along our horizon. Now, of course, if we have a Big Dipper and a Big Bear, we must also have a Little Dipper and Little Bear, because why call one big if we don't have a little one? Now, the Little Dipper can be tricky to find, but you can use the Big Dipper to help you. So what we're going to do is find the front 2 stars in the cup of the Big Dipper, and we're going to follow the line that they make until we reach this bright star here named Polaris. Polaris is also known as the North Star, and it's the end of the handle of our Little Dipper right there. Now, typically with the Little Dipper, you can see about 3 stars easily. Seeing all 7 stars of the Little Dipper is much harder because the stars are pretty faint. So you've got to have really dark skies and really well dark adapted eyes to see all 7 stars of the Little Dipper. Our Little Dipper is also our little bear, where again, the handle is the tail of the bear and the cup is the entire body of the little bear. Now, Polaris, as I said, you may know as the North Star. A lot of people believe that that must mean it's the brightest star in the night sky, but that's not the case. As you can see, Polaris is, about average. There are some stars that are dimmer, there are some stars that are brighter. What makes Polaris special is the fact that it's the only star that doesn't move. So if I fast forward time here, we can see that as the Earth rotates and makes it appear as if the sky is rotating above us, all of the stars move except for Polaris, except for the North Star. That's because Earth's North Pole is pointed right at Polaris. So while Earth spins around the pole, we see the sky spin around that same point. So Polaris is important because it stays still. It stays there, and it's always going to be in the same position in the direction of north. So it's important for navigation. If you can find the North Star, then you know north and you know your other directions as well. All right, I'm going to go back in time, back to where we were. I will say if you go out and you see the sky spinning in this direction, you might want to make a doctor's appointment. All right, and I'll jump us back. There we go. Right back to where we were around 9:25 at night. All right. So a couple of other constellations to point out. First up, though, cutting through the northeast, you may start being able to see this fuzzy band. That fuzzy band is our Milky Way galaxy, the galaxy we live in. And running right through it, about halfway up the sky, you can see a W shape. That W is the Greek constellation of the Queen Cassiopeia. Now, yes, it does require a little bit of imagination to turn a W into a queen. Usually she's depicted as she's sitting on her throne. So this is how this program depicts her sitting in her throne. You may have seen other pictures. With some of these constellations, it does require imagination. It does require being, a little bit up to interpretation. So there are a couple of different ways that you can picture the constellations, and this is one of them. All right, last constellation here in the north for now. Right in between our Big Bear and Little Bear, you may notice that there is a line of stars. That is the end of the tail of Draco the dragon. And he winds his way through the bears, around the little bear, and back to the back of the planetarium where he's breathing fire all over, I guess, me right now. But it's okay. All right. That has been our northern sky. I'm now going to turn us to the west. Now, this is the same if you were to stand up and turn around, but I don't want to have to ask you to do that. So we're going to turn the sky for you. Over in the west, we're going to do a little bit more star hopping. We're going to go back to the Big Dipper, but instead of using those pointer stars, we're going to use the handle of the Big Dipper. Now you'll notice the handle is curved or arced. If you follow the arc of the handle, it will point you to this bright star here named Arcturus. So the saying is, you arc to Arcturus. Now, Arcturus is part of an interesting constellation. Um, this is Arcturus here. Let me actually, yeah. And then we're missing a couple stars. There we go. There's Arcturus. Um, I've had a lot of fun asking people this the past few weeks. So I'm going to open it up to everyone. What do you think this constellation is? A lion? Frog? I like that. So kite is a pretty common one that we get. Ice cream cone is another common one that we get. But this constellation, which is named Bootes, is actually a man. Yeah. Really looks like a dude, right? I told you, some of these constellations, you got to use your imagination. Yes, this is Bootes, the herder, the bear herder. So he is herding our two bears across the sky. Now, right next to him is a U shape of stars. This one doesn't require too much of a stretch. It's a crown. That makes sense. And if we keep following upwards after our crown, we reach our great hero of Hercules. And he's mid-battle right now. He's actually battling Draco. And so we see him mid-battle. Now, this is the first stop of the night where I want to show you something more than just constellations. On the kind of side of Hercules, there is an object named M13, Messier 13, or the Great Globular Cluster of Hercules. It is, in fact, a globular cluster, which through a telescope would look like this. A globular cluster is a group of stars. Globular clusters tend to have tens to hundreds of thousands of stars packed in really close. And this is one of my favorite summertime objects to look at through a telescope. With all of those stars, it kind of glitters. I see it as like kind of shimmering jewels. I know Braden in the past has described it as like a puff of glitter in the eyepiece. It's beautiful and something I highly recommend. You don't need a telescope if you have a pair of binoculars. You can find it as well. But it is right there, right in the side of Hercules. All right, let's continue over to the south. Over in the south, we can see the other half of the arch of the Milky Way. In fact, you may notice that it looks a lot bigger and brighter in this direction, and that's because looking towards the south in the summer, we are actually looking towards the center of our galaxy. And there's just a lot more stuff in this direction, so we see a lot more light and a lot kind of bigger appearance of the Milky Way. But you may also notice that there are these dark streaks cutting through. Those dark streaks are where we have clouds of gas and dust that are so thick they're blocking the light from the stars behind them from getting to us. And so it may look like there's nothing there, but there actually is. It's just the light is being blocked from our view. And right in the south is one of my favorite groups of stars. It's another asterism, and it's known as the teapot. And it does actually look like a teapot. And you've got the Milky Way is like the steam coming out of the teapot there. This is, again, an asterism. So it is part of the constellation of Sagittarius. Sagittarius is a centaur, so half man, half horse. And I got to tell you, even turning the picture on, I struggle to turn a teapot into a centaur. But
I think I figured it out.
Yeah.
Actually, yes. This has been me tinkering with this idea for about 2 months now. I think I finally kind of see how it makes sense. Where's the
They're up there.
So the best way I can describe it is going to be with this being the tip of the arrow from the bow. This is the bow right there. He has both the arrow and his arm holding the bow.
Ah.
This is like his. This is going to be like the front horse legs. This is his other hand holding the other bow. This is like his neck and like head right there. And I see like this, I don't know, like horns or something like that. And then the rest of his body kind of goes out.
And you kind of have to imagine the
Yes.
rest of the body. Okay.
But that I think makes a bit more sense.
Does the cloud in the Milky Way ever disappear? Is that what you asked? So technically yes, but we're talking over hundreds of millions of years. I can fast forward time a good bit, but the physics involved in the dispersing of gas clouds, I'm not sure if it's fully coded in for that. So yeah, maybe if we have time, we'll see how far I can go and if it changes. But I kind of feel like they didn't bother with the physics of that. All right. I'm going to now turn us to the east for our last set of constellations. Now, first up, high up overhead, you can see 3 bright stars which trace out what's known as the summer triangle. We have the star Vega, the star Deneb, and the star Altair. And they make a triangle which is visible in the summer. Summer triangle. Makes sense. Now, each of these stars is part of its own constellation. The star Vega is part of Lyra the lyre, or Lyra the harp. A lyre is an early stringed instrument. So you can see that there. The star Altair is part of Aquila the eagle, which I have to say, with just the lines, it looks a lot more like a manta ray, in my opinion. But there is our eagle flying through the sky. And last up, the star Deneb is another bird. This is Cygnus the swan, which does actually look like a swan, right? We got the wings and the long swan neck as he flies through the Milky Way. Now, in this region, we have a couple of other really cool things to look at through a telescope. We have, first, near Lyra the harp, right in between those 2 stars there, we have M57, the Ringed Nebula. And it would look like this. This little ring is a gas cloud. That's what nebula means. And it's the result of the death of a star similar in size to our sun. What we see here is all of the outer layers of the star, all of that gas that was pushed out as the star died. And while that gas is hot, it will glow, and we see that glowing gas, and we call it a planetary nebula. Nothing to do with planets. It's a little misleading of a name. So this is the Ring Nebula, and in fact, this is what's going to happen to our sun in about 5 billion years. We have a while. And then another planetary nebula in this region is about a third of the way, half of the way between Altair and Deneb. We have the Dumbbell Nebula, which kind of looks like a dumbbell, hence its name. I'm telling you, astronomers are not clever when coming up with names for things. For example, there's a really, really big telescope, and it's called the Very Large Telescope. Literally, that's its name. Not even kidding. Yeah. But that is the Dumbbell Nebula. It's another planetary nebula, so the result of the death of a sun-like star. All right. Now, lastly, here in the east, we are finally starting to get a peek at our fall constellations. So first up, before we get to a constellation, a highlight of the fall sky. What we're going to do is we're going to go back to that W of Cassiopeia. And if, yeah. Why is what? Oh, okay. So why is Altair stealing a small child? So this is Aquila the eagle. He did a lot of errands for Zeus. What we're depicting here is him carrying up Ganymede, who Zeus really liked and wanted him to come up to live with them up on Mount Olympus. And so this is Aquila carrying Ganymede up to Mount Olympus so that he can live up there with the gods. Yeah. He's who eventually became the water bearer, or Aquarius. So that's him. All right. So back to our W, back to Cassiopeia. If you take the right part of the V, there we go. The right part of the V, and you think of this like an arrow, that arrow will point you to this little fuzzy blob here. That fuzzy blob is the Andromeda Galaxy. You can see it just like this with your eye. You do not have to have a telescope. You just need the right time of year and a dark enough sky. Now, with a telescope, it will show more detail. So the Andromeda Galaxy is the closest major galaxy to us at about 2.5 million light years away. It is a spiral galaxy just like ours. And our Milky Way is actually on a collision course with the Andromeda Galaxy. The two will collide in about 3 billion years. Galaxy collision sounds a lot more crazy and scary and chaotic than it really is, because galaxies are mostly empty space. There's a lot of space between stars. So when galaxies collide, you don't have just stars and planets ramming into each other, exploding, all of that. Really, the two just kind of merge together and become one bigger galaxy. In the case of these two, the proposed name for the combined Milky Way and Andromeda is currently Milkdromeda, which I hate. But we have 3 billion years to come up with a new name. So I think hopefully we'll come up with a better one. Now, this is called the Andromeda Galaxy because it is right next to the constellation of Andromeda, which we can see right here. Andromeda is actually the daughter of our queen Cassiopeia. So Andromeda is the princess. And her father, the king Cepheus, is on the other side of the queen. This like upside down house shape is the king Cepheus there. All right, now I'm going to turn off the label for Andromeda because this next constellation, well, I'll leave the circle on. This next constellation really deserves some respect. Here we go. It's 4 stars sitting right in the east. Everyone behold the Great Square. Its full name is even funnier. This is the Great Square of Pegasus. You know, Pegasus is a flying horse. How you get a flying horse from a square, I could not tell you. But I read an interesting fact the other day. Right around when a lot of these constellations were being made was also around the time that they started fermenting things and brewing beer. I wonder if there's a correlation. But yes, that is the Great Square of Pegasus, my absolute favorite constellation. And to round us out, right below our Queen Cassiopeia and our Princess Andromeda, our last fall constellation, is our great hero, Perseus. Now, Perseus, in his picture, you will see, is holding the head of Medusa. That's his claim to fame. He's the guy who killed Medusa. And this bright star in the head of Medusa is named Algol. It's actually where the term ghoul comes from. This is a reddish color star, which over several days, if you watch it, it will actually dim and then brighten back up again. That's because Algol is actually not one star, but two stars. It's part of what we call an eclipsing binary. And as those two stars rotate around each other, every so often, one star goes behind the other, and some of that light is blocked. So we see the star appear to dim periodically over several days. And we have this basically red, blinking, angry eye of Medusa. And again, that's where our term ghoul ends up coming from, is this star named Algol. All right, last thing to take a look at, we do have some planets that are visible. We've got hanging out over in the southeast, Saturn making an appearance right after it gets dark. Now, to just your eye, it's going to look as a point of light, but through a telescope, we can make out the rings of Saturn. And just coming up, actually, it is not up yet, so we're going to go. I know there's another one. Neptune. Neptune's the other one that's up right now. Neptune's trailing behind Saturn. It's not one that you can see with your naked eye. You do have to have a pair of binoculars or a telescope to see it. But with that, you can actually make out that blue color of the planets. All right, now if we keep going into the night, not too long after it gets dark, we have two more planets rising up over in the east. We have Jupiter and Uranus. Now again, Uranus, like Neptune, you have to have a telescope to see, or a pair of binoculars. You can't see it with your naked eye. Jupiter you can, but with a telescope, you will be able to make out the stripes. Depending on when you're looking, you may also get a glimpse at the great red spots. And usually around it, you can see the four largest moons of Jupiter, known as the Galilean moons, as Galileo discovered them. For tonight, we have the moon not far behind Jupiter and Uranus, but this is slowly going to change from day to day as the moon makes its way in its orbit around the Earth. And then as we continue, we get starting to get a glimpse at some winter constellations, because winter is up next. But just before the sun comes up, we've got Venus rising up in the east and will be pretty visible in the pre-dawn sky all month long. So if you're looking to the east just as the sun is coming up and you see something really bright, that is Venus. And with that, we have our sun coming back up, bringing us back into the daytime and bringing us to the end of our show. So that has been a glimpse of what you could see up in the September sky. Lots of fun stars, constellations, deep sky objects, and planets are going to be there. So a great time. We do have out on the table in front of the TV at the main entrance, there are some star charts. Feel free to take one of those. It can help you find all of these things we talked about here tonight. And also, as you head out, we will be passing out eclipse glasses that you can use for the upcoming solar eclipse on October 14th. Just be sure to keep the film on the glasses. Make sure those don't get scratched or punctured, because that is what's going to protect your eyes so that you can safely look at the solar eclipse. We will be here if you have any questions. Otherwise, thank you all so much for coming out. I hope you enjoyed the show and have a good rest of your week.
So the solar eclipse will be out there in the world?
They're going to pass them out.
No, I mean the solar eclipse is actually going to happen?
Yeah, on the 14th, October 14th.
Out there?
Mm-hmm.
Not in here, right?
Nope, outside. Yeah.
So I heard they discovered like